Hello everyone, I am Agent FUD. I'm a Python and a smart contract developer. In my everyday life, I do Python coding and AI, mainly image recognition. So I love well-tested code and art. So guess what? When NFTs came to light, I really wanted to create my own. So I met with my designer, we discussed the idea, I gave her instructions, and she delivered all the parts of the images what I wanted. But unfortunately, I checked the market and there were no software which could build those wonderful images from those parts. Here's an example. So because of that, I decided to create a software which can build images from sprites and also which can handle complex traits. So what are the complex traits? I will explain it to you later. So if you want to connect me, I'm available in Twitter, as you see here. Is my GitHub repo, and also you can find me on OpenSea. So why I decided to create a new software again. So first, I didn't want to restrict my designer's creativity, and I couldn't find the proper tools, and I found two major problems. So first, managing complex traits is a really big challenge, and I don't know if anyone ever wanted to do that, but I really want to do, and I will show you what it is and how I'm gonna do it. And also, the second problem was how to manage rarities properly. So imagine if you wanna create your own NFT collection, let's say where the initial price reflects the actual rarity of the art. So in that case, you really want to be sure, even before launching, that the rarities and the generated images and the images traits are aligned. And lastly, but not leastly, I want to give you the best available tool and software on the market. The GitHub repositories, they will be always open, and I will never close them. And if you want to create your own collection, so let me introduce you into how to generate wonderful images with a bit of help of Python and of course a really good designer. For this series I will use Python 3.8. I will use a couple of features which are not available before version 3.5. So please follow the instructions and you should be okay. So what I'm gonna cover in this video, as I told you, I'm gonna show you how to generate these kind of images from small parts. Are you ready? Great. Let's write my keyboard and jump into coding. First, I'd like to show you the actual output of the software. First, I'd like to show you the actual output of the software. So this is a generated JSON file. It is a metadata file, and this is the corresponding image. As you see, it has 10 traits. The background is light blue. The background 2 is clouds. Maybe I will rename it. I don't know. The color is white. Body is a body. This cat has only one shape, and it has ear, tail, mouth, foot, and thigh. In this video, the goal is to create a software which is able to generate these kind of images and metadata. And I really want to try uh, if I can do it in less than 100 line of codes. I think it is possible. So please keep in mind, this way of doing things is just a quick and dirty way. Later on in next episodes, maybe I will review the code and make it much more readable, testable, and so on and so forth. So first, check out the GitHub repository. As you see here, this repository contains only a README file, which explains what this software is doing and how it works and how you can install it. So let's get the software and start coding. So the first option to get the code is through HTTPS. HTTPS and SSH requires you to have a GitHub account, and you have to log in order to get the code if the code is closed source. But with HTTPS, you can clone it with the Git client without even giving you a password. So what I recommend for artists, later on I will create releases and download those releases and follow the instructions. But right now, let's start with cloning the project. I open a code editor. All right. So I use Microsoft Visual Studio Code, and I'm really happy with it. But you guys, you feel free to choose whatever code editor you like. So first, I want to show you what I got from my designer. So she gave me this folder with the images. So it contains two subfolders, colors and single. First, let's check out the single folder. As you see, here are the background 2, body, ear, eye, blah, blah, blah. So this one is actually all right. So let me get the JSON. So let me get the JSON file. So let me get the JSON file. All right. So as you see, the background. So the trait types are listed here in the single folder. And actually, there is one trait type, which is color, which is not listed here. And this is the corresponding folder. Right now I have two subfolders, greenish and yellowish. So let me pick up an ear. So if I go here, you see, if I want to color the image, when I show the ear down image, if I want to colorize it, I have to get from the corresponding colored folder the down, which is the colored one. And you see, this is a normal and this is a normal line. So this is how the coloring will go. And what you see here under the colors folder, those are the complex layers. Why I'm saying they are complex? Because in order to have one which is complete, you have to have at the same time the body, the ear, and the tail, and you have to paste it into your image. So let's create some code. I'm going to close this folder and create a new Python file. So first of all, what I need is those list of traits, the single ones. So fortunately, she sent them to me. So those are the traits. And as you see, I listed the complex uh, trait here as well. So we have to find a way how to distinguish between a single and a complex layer. So for this, I will create a dictionary called colors. So I have two of them, greenish and yellowish. It's gonna be an array. So, and it has three subfolders: body, ear, tail. All right, and the same applies for the yellowish. Okay, so some sort of configuration option if I uh, create a list, let's say available colors, and I will list here so how the software will work. So let's say if I have three different colors, and if I want to use only the yellow, what I will do, I will use just only this one. But for our purposes, this is what we have. So first, I want to collect all the available options for those traits. So trait option is gonna be a dictionary. Dictionary, I said, and there should be something. We don't know what. So for all the traits, what I have in this trait list, except is when trait name is not color. So what I'm gonna put here, that's gonna be a dictionary. So trait name, and here I will list all the options what I have. So for that, I have to find all the images in that particular directory. So for that, I need a module. It's called OS. So OS path, and I don't want to have the PNG, so I'm gonna split text the X, and I only need the first item for X in OS list dir. Now what I have to do here, layers and single. Yeah, and also layer single plus trait name. All right, check it out if it works. So yes, I have a problem because I don't have ties, so I have to remove it. Let's check it out again. Good. All right, so as you see here, I have all the directories, and with the directory names, which are the traits, I listed all the sprites in our list. All right, so, but it is not full because for the trait options, I have to add color, which I handle differently. Those gonna be the colors. So if I run it again, you see, I have the color. Good. So with this trait options dictionary, actually, we can tell what is the maximum possible combination of these sprites. So simply by just counting how many items these lists have and producing them together. So let's do that, okay? So the max possible combinations. So I need list comprehension, and also I need a new package. So first I'm gonna create a list comprehension to count all the numbers of trait options for T in trait. So this part is fixed, I'm pretty sure, and what I need here, the length of the trait options T. Yes, and what it will give me, that's gonna give me a list where every single item gonna contain how many items has this one. So it's gonna be 1, 1, 2, 3, 4, 5, 2, 3, 3, and so on and so forth. And why I imported the math package, because actually it has a great function. It's called the prod, which takes a list as an array, and right now I can print out what is the maximum possible combination of these traits. All right. So let's see how it goes. All right. I have a problem. Oh, I forgot to activate the environment. And create it. Okay. I'm installing all the requirements. And right now, it should be okay. Wow. So it spits out the number as it expected. So you guys, you make sure. So Python minus version gives you a bigger number that's 3.5. That's crucial. All right, so let's generate some DNAs. So what is a DNA? So if we come back here, we see that all the options are listed here. So a DNA is, let's say, a configuration where I pick exactly one from these options. So for example, the body from the body, and the classic from the eye, and the clouds from the background, and the scared for the tail, and so on and so forth. So how we can do it? Uh, let's do it in randomly, and let's say we will generate 10 of them, okay? So the actual DNA is gonna be a dictionary. Let's go through to traits. And for every single trait, uh, uh, so this is the key, the trait name, and for every single trait, I will pick a random element from that actual list. So it's gonna be trait options T, and I have to tell which one I wanna pick. So, and I want to have a random number. Yeah, and I have to import it. Random number, which goes from 0 to the length of that actual trait. So the trait options T, and because the len gives me 5 or 8, so one bigger than it expected. So for example, for this, the len will give me 3, but the indexing goes from 0, so I have to distract 1. All right, and finally, I have to push the DNA to DNAs. So let me see what we get. All right, so there is a key error. All right, so I got the error. The problem is I don't need to add the colors. I have to add the available colors because this is the abstraction that I'm using. The color actually has two options, yellowish and greenish. All right, so once I changed it, so if I run at the end, it gives me the DNA's array. So what it contains 10 different DNAs, and you see the keys are the same and the actual values are different. So light blue, and random. So here it's pink, it's purple, lavender, and also the ear normal. Let me highlight the ears normal, 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 down, normal, normal, up. So this is what I will have in the DNA array. All right. So the next step is to generate sprites. What are the sprites? So sprites are basically lists which contains the full path of an image, and it is ordered. So for example, the first sprite will contain, let's say, this one, like this, and the second one. This is the background and something for the background color, and this is how it goes. So how are we gonna do it? So because the DNA defines the actual image, I have to go through all the DNAs. That's for sure. So let's create a sprite config, an empty one, and we're gonna fill it based on the DNA. So I will loop through the DNA item. So trait name, value in DNA items. So, and this is where I have to distinguish, because I have to deal with differently if the trait name is color. If trait name equals color, I will just pass it. Else, because this is the simplest one, sprite config append, and I need to look for the actual image. So this so layers, single, and I have to provide trait name slash trait value, that's png. All right, so let me see what we got. I forgot to add it to the list. All right, so let's run it again. And I have a loads of it. Maybe I will limit the numbers because I really want to see how it goes. All right, so let me get it. Yes, and basically this is it. So for every single one of them, I have a background, and all right, so let's do it. So the sprite configs, that's an empty list. Let's loop through to DNAs. The actual sprite config I need here. Initialize as an empty list. And I need to loop through the DNA items. So the actual DNA items, and I check if the trait name is color because I have to treat it differently. I will do something, but first I will do the second part. When it is not a color, so, and if it is not a color, the actual sprite config, I will append single string, which is so layers, single, and trait name slash trait value dot png. And at the end, I have to push it to sprite configs. The actual sprite config. Right. So here, what I have to do, it's a bit different because I have to loop through these items and I have to find the corresponding values. Trait name in colors, trait value. Mhm. So the image name is actually the actual value, and I have to append to the sprite config something different. Layers complex colors. So, and here I need the trait value and the trait name, the internal one. All right. The fix was quite simple. Here I added a complex subfolder which doesn't exist. But right now, if I'm doing like this and I'm running, I can even generate 10 different images. So let's check it out. And we have software generated beautiful cats. Good. So right now, what I need a function which can generate me metadata. So it also gets an ID, and I think the DNA would be enough. So the attributes has to be initialized as an empty list, and for D in DNA, so remember the DNA consists key value pairs, where the keys are the trait types and the values the actual values. For D in DNA, attributes append so no, not like this. I'm gonna append the dictionary. The first key is trait type, it's a D. The second one is the value, which is the DNAD, the second element. And I'm gonna import the time package. Because I'm gonna add the time as well. So this time gives me back the Unix timestamp. And let me build the metadata. It's gonna be a template, sort of. The first key is the name. Let's I will set it to ID, what I got here. The next key is gonna be the description. All right, next key is the actual image. I don't have it anywhere, so I'm just gonna fake something. All right, the image is the next one. The date when I generated it is gonna be the date. Date's gonna be that one. Attributes gonna be the attributes. Attributes what I've just created. Let's say I add last key. So what is the engine? What is used to generate it? And at the end, I have to return the metadata. Or I can save it here. Uh, I will save it here. Later on we will. Alright, so build images metadata. So how to save a JSON file. So I have to give it the file name, build metadata, ID, the JSON. Also, I'm opening it for writing, just to be sure. I'm giving it an encoding as F, JSON dump, metadata F, AngelASCII false, and ident gonna be 4. And I have to import the JSON package as well. Alright, looks like it works, so let's try it out. I need a DNA for it. So index and DNA, that should be it. Let's try out. Ident is not found. Yes, it is indent, not ident. Let me generate it once more. All right, got no error. So here is the JSON file, and here is the first image. So if we compare them together, Background is purple, background cat 2 is cartoon, it's purple cartoon, color yellowish, yes, it is yellowish. So ear is up, tail is curvy, ear is up, tail is curvy, eye is black eye, mouth is screaming, eye is black eye, mouth is screaming, and foot is normal, which has only one single trait. Alright guys, so basically this is it. Let me finish the video and let me know what you think about this video and the content, and leave me comments on YouTube. Thank you for watching. See you next time.